This is to explain the cutting velocity difference in conventional drilling and UVAD drilling. So I have a drilling tool model, and we can see this is a tangential velocity, the green one, tangential velocity, and it's act on an oblique element here, because if we clearly observe, it has a inclination angle from the element to the uh, cutting velocity factor. And because of we have a drilling angle here, and the z axis is on this direction, so uh, if we able to sketch another cutting velocity in UVAD, it will be having in this direction, because of the z direction, the vibration is on this direction. Yeah, so if I turn off this, hide this one, so this is the new cutting velocity in UVAD, and this is the oblique model. So back again, now I will firstly explain uh, on the conventional drilling. So if we take one element and we detail observe that, we have this uh, oblique model, which is uh, approximately the same as before, and this is have a P angle here, and this the green arrow is the um, tangential velocity. In conventional drilling, it is equal to cutting velocity. So it look like this. And if after doing the simulation, so I use a certain number here. The inclination is 4.67. So if we look from the top, it will look like this. So this is the cutting edge, and this is the tangential velocity, and it has an inclination angle 4.67. And in the cutting mechanics, we need the normal rake angle and the equivalent rake angle to calculate the cutting force. And to obtain the alpha n, the normal rake angle, we required to draw this OA line, and the OA line is sliced on the rake face while it is perpendicular to the cutting edge. So it is I can draw this line OA, and I can measure the alpha n, which is this value in this case, 55.69, to the a line that is perpendicular to the uh, tangential velocity. So it is the OA and the alpha n is on this plane that is normal to the cutting edge. But the chip flow will be not on this OA line. It will be on OC, which is slightly inclined, and to the Stables rule, that the chip flow will be approximately the same as inclination angle. So I can draw a new line, which is OC, that is inclined with 4.67, almost equal to the I. So the chip will be flow on this direction. So if we take a look from the top, it will look like this. The chip will be go to here. And if we look at the UVAD cases, it will be look like this. The same oblique angle is tilted with a P degree because of the geometry of the drilling tool. And this is tangential velocity. If we take a look, yeah, this is the tangential velocity acting on this cutting edge. This is the oblique element. And we have the oscillation velocity here in z direction. So the resultant, the cutting velocity, will be this green arrow. And if we take a look from the top, it will be look like this. Because of it's acting on the same element, so the inclination angle will be the same. Will be the same as before, and the OA line will also the same because OA should be lies on the rake face and also perpendicular to the cutting edge. Yeah, so that's why. But the OC, where the chip flow, it is depends on the direction of the cutting velocity. So now I'm taking a normal view to the cutting velocity. Maybe it will be look like this. Now this is the tangential velocity and this is the uh, oscillation velocity. So it will be look like this. And if we see that, uh, it will be the rake angle will be negative. Will be negative. But the inclination angle will be changed from from the previous value. So maybe I will see from the top view of this. Yeah, rotate like this. Yeah. So this is the uh, cutting velocity. Go that way, and this is the cutting edge. And when I measure the inclination angle, the new inclination angle will be this, the I underscore C 31.26 degree, and it is now above the horizontal line. Now the inclination angle relative to the cutting velocity will change to 31.26, where previously it is 4.67, 67, yeah. And following the Stable's rule that the chip flow angle will be approximately the same as the inclination angle, and we have a new inclination angle 31.26. So I can now draw a new OC line, this one, which is having inclination angle 31.26 degree. Yeah, I can draw this line, and also I can measure the alpha E now. The alpha E in this value, now it is 5.79, but it is negative. Actually, it is negative because you can see it is negative rectangle. And the alpha N also I can measure. This is negative also, 25.69 65. Yeah, this is also negative. And yeah, this is to explain why the inclination angle will change when we have the oscillation velocity added to the drilling tool. Yeah, or maybe I will. This is the top view of the oblique. This is the front view, and this is the isometric view.